If you've ever wondered what a black hole sounds like, you're not alone. NASA has released the first ever recordings of what a black hole sounds like and has sent a wave of chills down everyone's spines. In this video, we'll give you everything you need to know about this amazing discovery. According to Einstein's theory of spacetime, the universe is full of vibrating energy and is far from silent. The vibrations of space and time have as many textures and timbres as the sounds of a tropical rainforest or the climax of a grand opera. Truth be told, we just haven't picked up on those sounds before. Everything we've seen has just been a silent film adaptation of a musical called The Universe. Thankfully, astronomers have developed a means for humans to hear them, allowing us to not only see, but also feel the dynamic cosmos surrounding us. The sound you'll hear will be of the black hole at the heart of the Perseus cluster of galaxies. Brace yourself, as what you'll listen to will seem like a strange, angry-sounding howl raging from beyond the stars. Is this the sound you'd expect from a supermassive black hole? Since 2003, Perseus has been linked with acoustic connections. This is because astronomers found something remarkable. The pressure waves emitted by the black hole generated ripples in the cluster's heated gas, which could be read as a musical note. But the note's too low. So low that, in fact, it represents the lowest note that has ever been identified in the entire universe. However, a new sonification has added several octaves to the recording, raising the pitch of the notes. They took the notes identified in 2003 and added new ones, giving us a better idea of what the black hole would sound like as they echoed around the cosmos. It is through this method that NASA was able to release the black hole's sonic signature. I know you're wondering how we heard it. There is no sound in space since most of it is a vacuum. Thus, sound waves can't travel there because there is no medium like air to transport them. The sound we hear in science fiction films, like rockets roaring by, is artificially added just to make the action more exciting and, ironically, more realistic. Our human ears can't detect any sound in space. Still, this does not mean that there is none at all. Through sonification, we can replace the silence of the cosmos with the sounds of instruments to represent the data collected. Moving between the data points is like listening to an orchestral composition of a nebula, star cluster, supernova remnant, or cluster of galaxies as observed at different frequencies. Volume and pitch would acoustically express differences in brightness or distance. For instance, bright stars could be represented by higher pitched notes. A depiction of a star's explosion could also build to a climactic roar before fading into softer tones as we move away from the blast wave. The first audio clip you heard is the pressure waves or sound waves from the supermassive black hole found at the center of the Perseus cluster of galaxies. Frequent explosions happen there, creating a ripple effect around the clusters with a wavelength of 30,000 light-years propagating outward through the thin, ultra-hot gas that permeates them. So that we may hear the sounds coming from all sides of the supermassive black hole, the waves were extracted radially or outwards. It was then played counterclockwise from the center. This raises the pitch between 144 quadrillion and 288 quadrillion times the original frequency. If they had to boost the pitch that high, just imagine how low the original sound was. It was 57 octaves below middle C, which is much below the sonic threshold of the human ear. Astronomers believe that these waves prevent new stars from forming because it keeps the gas temperature in the cluster too high for fusion to happen. That's why the sound waves had to be transposed up to 57 and 58 octaves for us to hear it. As a result, it sounded like a sinister wind tunnel or galactic growl, much like other space waves that have been converted to sound. There are in fact other recordings, and black holes can be sonified in ways that are far more pleasant to hear. The black hole in the heart of Messier 87, or M87, has also been sonified by NASA. It is a galaxy approximately 54 million light-years distant. M87's black hole is the very first photograph the Event Horizon has taken. Data such as wavelengths from this photograph and other visuals from various telescopes are converted to a musical scale. The sound is nothing like what a real black hole would make. Instead, it might be something that you could find enjoyable during your next yoga session. What makes it different from Perseus's black hole is how it was sonified. Instead of pressure waves, like in the Perseus audio, the data collected was light at various frequencies. The lower the frequency of the radio data, the lower the pitch in the sonification. The sonification starts at a low pitch for the radio data because it is at the lowest frequencies. Optic information sits in the middle, while X-rays take the upper end. According to Einstein's general theory of relativity, black holes are objects with such a high center of gravity that not even light, much alone sound, can escape. They can be the darkest objects in the cosmos, but also shine the brightest. Theorists suggest that before matter completely vanishes into a black hole, it is accelerated to near light speeds by its gravitational field and heated to millions of degrees as it swirls about the hole. As a result, X-ray bursts would be triggered, interstellar shockwaves would be created, and high-energy jets and particles would be expelled throughout space like toothpaste. One scenario is where a black hole exists in a binary system with a star and robs it of its material. It then piles up into a thick, bright disk, or more like a visible donut of doom, which occasionally unleashes X-ray bursts. The echoes or reflections caused by these X-ray explosions were then transformed into an audible sound, resulting in the sound we have heard coming from M87. But NASA has not only caught the sounds of these black holes, they have also recorded a spiral galaxy soundtrack, the artist being 69 million light-years away from Earth. A barred spiral galaxy, NGC 1300, can be seen in the southern constellation Eridanus. Its arms are adorned with a constellation of newborn blue stars, cloud formations that look like cotton candy, and dusty black pathways. Images from the Hubble Space Telescope paint a vivid picture of the history of this galaxy. But what about its soundtrack? The music is probably right in line with your expectations. A dreamy new age tune with a chiming synthesizer, befitting a surreal setting. Anyways, here's the audio for you to judge. A lot of sound from the intergalactic space these days is created by converting digital data acquired by telescopes into various colors of light. In this way, cosmic objects like X-rays can be seen by human eyes. Sonifying NGC 1300 requires scientists to give different brightness and position the image in a particular pitch and volume. The more intense the brightness is, the louder the sound is. And the further it is from the galaxy's center, the higher the pitch of the sound. Of course, there's an entry from our solar system too. It's from our very own Martian neighbor. The Mars Perseverance rover has already picked up some recordings, the first robot to record noises on the red planet using a real microphone. The sounds include the rover's metal wheels clattering over the sandy surface of the desert, a laser zapping a rock 30 times, and the sound of wind blowing on Mars. Initially, they may sound somewhat normal, but when you understand that you are listening to sounds on another planet, of our own robot moving on the surface, and a laser vaporizing a little bit of rock, all these sounds suddenly become meaningful and astonishing. You want to put on some headphones to fully experience the sounds of our Martian friend. More recordings from Mars are probably certainly on the way. Perhaps even in the future, missions will be able to transmit sounds from distant worlds when they return from places like Titan and Europa, two of our solar system's moons. Sure enough, our explorations into space have afforded us unique firsts. A problem has arisen, though, with one of our spacecraft buddies. Strange information from the Voyager 1 spacecraft's journey across interstellar space has baffled NASA scientists and engineers. Now, the orientation readings seem to be randomly generated or don't correspond to any situation in which the spacecraft could be. But at almost 45 years old, Voyager 1 and 2 had lived well past their predicted lifespan, so unexpected events are practically expected. There's no spacecraft that's ever flown into the high radiation environment of interstellar space, so it's no surprise that NASA is receiving garbled transmissions from there. Being 14.5 billion miles away from Earth, let's just cross our fingers that our spaceship pal isn't being hacked by aliens. Do you find the sounds of the cosmos exciting or frightening? Share your thoughts in the comments section below. Don't forget to hit the subscribe button and leave a like. Thanks for watching.